This is section 132. We're going to take a look at the domain and range of a function. So we're going to find the domain of a function in this lesson. So let's define it. Suppose a relation f describes y as a function of x. The sets of x and y coordinates are given special names. The set of all x coordinates of these points in our function is called the domain in f. And the set of all the y coordinates of these points in f, we call that the range. So the x coordinates are the domain, the y coordinates are the range. Now, we can look at it very simply. What if we have a set of points? So if we said that the domain are just the x values, that means our domain is just going to be those x values there. And so we list it. We use the roster method where we're just listing them, and I list those individual x values, -3, 0, 4, and 5. And then now for the range, we look at the y values. Now in this instance, I just have two of them, just 1 and 2. And again, list it using the roster method. We're just listing values, and I use the values 1 and 2. But what happens when we have a graph? And we no longer just listing points, but we actually have, it seems, an infinite set of values. So what we're going to do is we're going to project the image of the graph onto the number line. Now what that means is imagine you are taking the graph and you're squishing it. Like if I were to take this graph and you just took your hand and you pushed the graph down until it's flat on the number line, right? That open circle gets pushed down, gets pushed down, gets pushed down, gets pushed down. This gets pushed up, and it goes on forever. So it just keeps getting pushed up. And then if we take every single value and we do that, what ends up happening is we get this solid open circle with this line going forever that way. That is what we're going to look at to determine our domain. Now, if I just rewrite that number line off to the side, that's what that's going to look like. Well, we've practiced looking at number lines and being able to write the set or the interval notation of what that's going to be. And in this case, the domain is going to be, starts from -infinity, and it's going to go all the way to 1. And that's our domain. So that's what we're going to do, is we're going to project it onto the x-axis. Now, if you wanted to guess, if I wanted to find the range, I'm going to have to project it onto the y-axis. And so we're going to take this, and we're going to project, 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 project. Imagine you squishing that graph onto the y-axis, and what is that going to look like? Well, we have a closed circle there. Now, I know we may think, oh, there's an open circle because of this, but it gets filled in over there because that side also gets projected. And so you're going to get this solid number line looking like that. Now, if I were to take that and write it to where it's a little bit easier to look at, that's going to, imagine, because this is -infinity, right? And this is 4. So all I did was just rotate it to get to there. And so that's just going to be from -infinity to 4. Now, a common mistake. Because we're so used to reading from left to right, from top to down, what ends up happening is we might look at this and say, oh, this starts at 4 and goes down forever. Remember, when we write our interval, it's always the smallest to the biggest. So even though we look at this and it's like, oh, it's 4 and it's going down forever, we still need to be, oh, well, what's the smallest number? -infinity, and it's climbing up to 4. So let's look at a few more of these. If I were to project, 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 project. So there's the domain. So that's going to just be the roster method. It's just going to be a list of those values. -4, -3, -2, -1, 0, and 1. And if I wanted to find the y values, project, 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 project. So that's just going to be, so that's the domain, this is the range. That's going to be -1, 0, 1, 2, 3, and 4. Now we do have to be careful, right? I didn't say from 4 to 1. That would be wrong because it's not all the values from -4 to 1. It's only these very specific values, and the same goes for the range. Now in this one, if I were project, 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 right, we end up getting this shaded number line. Project, 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 we end up getting this shaded number line. Now you assume it's closed circle unless it says open, so we have to include these values at the end here. But my domain is going to be from -infinity to -1, union, and then it starts up again here at 1, so from 1 to infinity. And then my range, project, 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 right? It's going up and down forever, so it's going to be a solid number line like that, -infinity to +infinity. So what did we learn today? We learned how to find the domain and range from a graph. Now how do we find the domain of the graph? We project onto the x-axis, and then we look at that number line to determine what the set of numbers are going to be. And then how do we find the range of a graph? We project onto the y-axis, and then we just do it the same way we did with the x. We look at the number line that's created, and we just write the set of those values. This does conclude our lesson. If you have any other questions, please leave them in the comments.